The other way that we can compare two groups is with paired t-tests. So before, we were talking about independent sample t-tests, and those are situations when where we have to deal with variation among individuals. And in paired t-tests, we also have that case. So when we want to compare things, when the people who are being compared, they differ from one another, and then also the two groups differ from one another, that can affect our measurement. So, for example, when I talked about whether people like Coke or Pepsi, that could be a test you do. But each person, so you could ask a whole 38 people whether how much they like Coke on a 1 to 5 scale, and then you could ask another 30 people how much they like Pepsi on a 1 to 5 scale, and those two groups would then be the inputs into a independent samples t-test. But unfortunately, one of the things that gets mixed into that is how much each individual person likes cola. So if someone doesn't like cola, they would say they don't like Pepsi, but then that would just lower and they were in the Pepsi group, that would lower the average for Pepsi, but it might not be that they care about Coke or Pepsi more, they just don't like either of them. So that would make us look like Pepsi was less preferred than we expect. So when you have that kind of individual variation that affects our measurements, a paired design helps. So in a paired version of that test, you would ask each person their preference for Coke and their preference for Pepsi, preferably in some kind of blind, right? That's what a blind taste test is. You give them one, have them rate it, and the other, have them rate it. They don't know which is which. That way you're controlling for marketing, any marketing that made someone like it beforehand. And then you can find the difference between those two measurements. So here's another example. Fingers measured in different classes. So you guys, we measured your fingers, your thumbs and pinkies. And so here we have distributions of thumb measurements in blue and pinky measurements in pink, of course. And you can see that they overlap. So the question is, are thumbs longer or shorter or roughly the same size as pinkies? So it's a similar sort of question as the independent samples t-test, right? We want to know, basically, are thumbs and pinkies being drawn from a population of finger sizes that can describe both of them? Or is there one population for thumbs, another population for pinkies, and they're hanging loose from each other? So we squint at this, and it looks like, okay, there's a little bit more blue over here, a little bit more pink over here, so maybe pinkies are a little bit longer. So we can, but going along with that previous example, what's varying across people is hand size. So we'd expect someone who's just bigger to have a bigger thumb and a bigger pinky. And so on the one hand, that makes this not appropriate for an independent samples t-test because the two people aren't independent, right? So if we had, what we'd have to do is pick half of our examples and say just them, we just use their thumbs, and the other half we just use their pinkies. But since we have both of them, we can find the difference. And that's going to control for whether someone's hand was big or not, right? If their hand is big, then we've got a little different, but their pinkies are just a little bit different, then we'll have that. So we can look at this distribution of differences. So the key thing with a paired t-test is that we're actually taking two variables, two measurements, and we're finding the difference between them for each observation. And then that ends up being a single sample t-test. We're just going to compare the average of this sample to 0, because that would be the null hypothesis. There's no difference between the two groups. So really, a paired t-test is you do a subtraction and then you do a single sample t-test, which you already know how to do, because we did it last week. So there's the mean difference. This is the null hypothesis. The mean difference is 0. And looks to me like more of this is over on that side than that side, so it might not be. So let's look at how we would do this. So mean 1 minus mean 2 divided by pooled standard error, that would be the test statistic. And the null hypothesis is no difference between the two groups. We've seriously violated the assumption that the two groups are independent, because each person appears twice, once in each group, so we really shouldn't use an independent samples t-test here. Paired samples t-test, the mean difference is 0 is our null hypothesis, the test statistic is the mean difference, divided by the standard error of the differences. So the differences, that's a new variable. Sample size is the number of pairs. So that's one big, and the sample size here is the sum of both sample sizes. So that's one big change, is that the paired test has a much smaller number of degrees of freedom. But that's okay because you should be more sensitive. So these two ends in this, these two tables are not the same, right? This end is actually like half of this one. So if we do that, pinky versus thumb is 0.0. So the average pinky minus the average thumb is about a 20th of an inch. But then the difference, the average of all those difference is about 0.08 of an inch, which gives you a t-statistic that is more than twice as big, and you have fewer degrees of freedom, but you get a highly significant result. So 0.05 is usually what we compare it to, so you'd say, yep. So this is an example of how the paired t-test can be more powerful than a single sample t-test. So it's great because it can reduce noise and improve insight, and it can also reduce sample sizes, so you get twice as much data per person. However, you have to be careful when you set up a paired test. You have to plan how to do it. Sometimes if you're measuring, like, so for example, the blind taste test, right? You had to make sure it was blind, and you have to keep track of who order. Like, order is important too, right? If everybody drank Pepsi first and then Coke in the Pepsi example, if the first test made, you have some soda and then the next thing doesn't taste as sweet, that could affect the rankings. So you'd want to mix around so that some people got Coke first and some people got Pepsi first. And then a lot of real-world examples, if you're going to do a marketing test, you ask them how they think about your product, and then you subject them to some marketing program. Then you come back and measure again to see if it changed. That requires 2 visits, and so that can really reduce the number of people you get data from. But oftentimes it's worth it. So a paired t-test is a really common and valuable tool in a lot of real-world examples, and I encourage you to wrap your brain around it.